in this question particularly, that is 17 meter. But 17 meter answer is not enough, because here something else. 17 meter we have 4 answers, and 4 answers we have 17 meter. 17 meter is 17 meter west, 17 meter south of west or north of west. So we want to calculate the direction also. So you can see here, this is east and this is south. So 17 meter, that is the right answer, but 17 meter south of east. So final answer we have, that is 17 meter south of east. This is our correct answer. Okay, I hope you are getting all the concepts, and main thing is the concept. Earlier I have told you that you don't need to concentrate on the question. You have to concentrate on the concepts. Okay, so okay, now moving for the next question. Next question is, Mangrene, a fisherman, is spearing a fish. How would he aim for the fish? Okay, this is the concept from the class 12. In the class 12, you have studied ray optics. Okay, ray optics was the chapter, and in that case, you have studied the reflection and the refraction. Okay, this is the question for the refraction topic. Okay, so first of all, we are trying to understand the question. First of all, suppose here is a fisherman. Okay, and suppose here is the real fish. Okay, real fish. Why I'm saying real fish? Because there will be virtual fish also. Okay, this is the real fish, and this fisherman want to spear a fish. Okay, this is the fish, real fish. So just we are writing here real one. This is the normal which is drawn from the fish, and this is our fisherman. If this is a real fish, then whenever first of all I want to explain a concept. If you want to see this pen, when this pen is visible to you, when the light strike on the surface of this pen, then the surface of this pen will reflect the light, and this reflected light will come to your eyes. At that time, this pen can be visible to you. Okay, suppose this is my hand. My hand can be visible to me when the light strike on the surface of this hand, and it will reflect the light, and this light come to my eyes. Okay, at that time. So in the same case, if fishermen want to see a fish, then what should be happen here? A light which is reflected or refracted by the fish, that should be come to the eyes of the fisherman. Okay, that's the concept. So suppose the light which is coming out from the fish, it is moving in this direction. Now what is the medium here? Here is water. What is the medium here? Here is air medium. Okay, so light is coming from the water medium to the air medium. As you know very well, the density of water is higher than more than the density of air. That is why this is denser medium and this is rarer medium. In the concept of refraction, you have studied, whenever the light comes out from the denser medium to the rarer medium, at that time it will deviate from the normal. It will deviate away from the normal. So suppose it is our normal. This light is not moving in this particular direction, but it will move in this direction. Okay, if medium will not change, if this is water and this is also water, then light should travel in this direction. But now here is water, here is air, and that is why light will deviate its path, and that is why it will move in this direction. Okay, so now fishermen can see this fish at this point. This is the virtual fish. This is the virtual fish. Actually, fish is existing here, but when fishermen want to see a fish, try to see a fish, at that time fish will be shown here. Okay, due to the refraction. Now the question is, how would he aim for the fish? How would he aim for the fish? If he would aim for this point, at that time fish will not acquire, and that is why he should aim below. And that is why the right answer, from above, from below, directly, or get lesser. So from below, from above, or at this point, from below is the right answer. Okay, so we can say that fisherman should aim for the fish from below, because he is seeing fish at this point, but actually fish is existing below. Okay, clear? Now moving for the next question. What is next question? The motion of a swinging pendulum in a grandfather's clock is an example of a simple harmonic motion, that we know very well. Okay, in a simple pendulum is a simple harmonic motion. Okay, which of the following affects the time takes to complete one swing of a pendulum? Okay, this question is all about the time period. This question is all about the time period. So we should know the formula of a time period, that T equals to 2 pi under root of L upon G. This is the formula of the time period of a simple pendulum, of a simple harmonic motion. By this formula, you can see that time period of a simple pendulum is depending on the two things. First one is the length of a string. First of all, I should explain you what is simple pendulum. Okay, in most of cases, all the person, this is the simple pendulum. Okay, simple pendulum. This is the length of the string, that is L, and this is the object which has mass m, and here, as you know, that the force existing mg, where g is the gravitational acceleration. Okay, so time period of this simple pendulum will be in motion in this direction, as you know very well that in this direction. Okay, this is the simple pendulum. So the time period is depending on the two things. First one is the length of a string, and second one is the gravitational acceleration. Okay, so in this question, what they want to ask, which of the following affects the time? Which of the following affects the time? Two things will affect the time. First one is the length of a string, and second one is the gravitational acceleration. Okay, so gravity and length of a string, these two things will affect. This will not affect. Mass of the pendulum will not affect the time period, and that is why the right answer should be both 1 and 2 only. Both 1 and 2 only. Okay, both 1 and 3 only? No. Both 2 and 3 only? No. 1, 2 and 3? No. So first right answer is both 1 and 2 only. Okay, very simple question, but you can answer this question by only knowing the formula. That's why you should have knowledge of a formula also, that is T equals to 2 pi under root of L upon G. Next question, which of these statements about sound is true? So first of all, you should have some knowledge about the sound, that when sound travel faster, when sound travels slower. Okay, we will study first of all the options, and that then after we will discuss about the answer. Sound travels faster through warm air than through cold air. Yes, that is right. Warm air and through cold air. Okay, this is the properties of the sound. Some properties of sound you should know, that sound travels always faster in the warm air compared to the cold air. Okay, whenever there is a cold atmosphere, at that time sound travels slower. So this is the right answer. So right answer, which of these statements about sound is true? Then this statement is true. Sound travels faster when there is less water vapor in the air. That is wrong. Okay, if less water vapor, then it is less warm, then it should travel slower. Okay, so that is why this is incorrect. Sound travels faster when it moves against the wind direction. That is wrong. Sound travels faster when its frequency is increased. Okay, you have to remember that the speed of sound is not depending on the frequency. You have to clear in your mind that frequency is a different term, and speed of sound is not depending on the frequency. Okay, so this is the wrong one, this is the wrong one, this is the wrong one. So right answer is this. Okay, particular in this is the common sense line. Okay, sound travels faster when it moves against the wind direction. If suppose this is the wind direction, sound cannot travel faster against the wind direction. Okay, in the same direction it can travel faster. Okay, so right answer is A. Next one, all of the following are true about weight except, means which one is wrong? Okay, we want to find out the wrong sentence for the weight. Okay, first of all, you should have some knowledge of weight. That what is weight? We have studied earlier. W equals to m into g, where m is the total mass and g is the gravitational acceleration. So which sentence is wrong for the weight? It decreases as the object goes above the ground. It decreases as the object moves towards the ground. It varies depending on your location. So we have three sentences. We want to find out the wrong one. Okay, but these sentences are depending on the g. Why? Because we are moving, we are at some different location. Suppose this is the surface of the earth, this is a mountain. Okay, so at that time when you are on this mountain, when you are at the top of this mountain, at that time you have some height, and you have to remember that in the formula of gravitational acceleration, you know that is gm upon r square, where r is the distance. So if you are going upward, your height will increase, and that is why distance will increase, and that is why gravitational acceleration will decrease. If gravitational acceleration decrease, then weight will also decrease. Okay, you have to remember this one. So it decreases as the object goes above the ground. So this sentence is true. Why? Because weight will be decreased when you go up above the ground. Now the second one, it decreases as the object moves towards the ground. If you are moving toward the ground, at that time your height is going to decrease, and that is why your weight is going to increase, because G is going to increase. If you are moving towards the ground, the R is decreasing, and that is why G is increasing. And if G is increasing, then weight should be increased, and that is why this sentence is wrong one. It decreases as the object moves towards the ground. So this is the wrong sentence. It varies depending on your location. Yes, it is right, because if you will change your location, your height will be different, your gravitational acceleration will be different, and that is why weight will be different. But this sentence is wrong. So 2 only. This is the right answer we have. Okay, now for the next. Next is we have Fonjal is swinging a ball at the end of the string around her hand. This type, okay. As she keeps on exerting force, she feels an outward force pulling on her hand. Okay, you have experience also of this case. Suppose string is moving in this, like at that time you will feel that there is some outward force pulling on her hand. Okay, what kind of force makes the object move in circular motion? Very simple concept. Okay, suppose this is the hand and this is the motion of a around her hand swinging a ball. So suppose this is a ball, okay, and this is the string. Okay, so you have studied in the circular motion that there is two forces. First one, which is in the outward direction, means opposite to the radius, it's called the centrifugal force. What is it? Centrifugal force. What is the work of this centrifugal force? It will always, this force will always have the direction opposite to the radius, okay, and this is towards the center. This is opposite to the center and this is towards the center, and this force is known as the centripetal force. What is it? Centripetal force. Okay, so what's the question? What kind of force makes the object move in circular motion? Then centripetal force is the responsible to move this in the circular motion. So it's very simple answer. Centripetal is the right option, and it is C.